Hello, class. Today is going to be the second part of the factoring video. The part one was the theory of factoring, like why we're factoring, what does factoring mean, like in the different factoring types. Then we did greatest common factor and factor by grouping. Today we're going to focus mainly on trinomials. There's a couple different methods that we'll talk about, and then we'll also do difference of squares. And then we'll do a couple of the messier factoring problems that have more than one technique, generally GCF plus one of the other technique. So today's main topic is going to be factoring trinomials. One note I want to throw out there just for factoring in general, again, because I know this is a topic that can be a little bit rough for some students, is like, even though we're going to use this other places this semester, the messy factoring that we're going to do is going to be concentrated in this unit and then this section particularly, and in the next section we talk about rational expressions. Later in the semester, we're going to do factoring. The factoring will be a little bit more basic, maybe not quite as messy. So just kind of keep that in the back of your mind. We're doing the hardware factoring now. Later in the semester, we'll do GCS, we'll do difference of squares, we'll do trinomials, but like a lot of trinomials are going to be some of the nicer trinomials. And so just all the factoring is not going to be as messy as what we're talking about today. All right, so as always, I will be using lecture notes that I've got posted in Blackboard. So if you go to the the study resources for Unit 1, under lecture note outlines, R5 is factoring review. And so this is what I'll be taking the notes from, or this will be a basis of a lot of my notes today. And so for the first part, we talked about like the general techniques. We went through all those different polynomials to identify, like, well, not all, but a lot of them to figure out what technique to use. Today, we're going to focus on page 3, and then we'll pull a few more examples back from page 2. But so we're still using the same handout that we used from part 1. All right, and then afterwards we'll jump into Blackboard into MyMathLab and see if there's any additional problems we want to do. So in that case, let me pop over to my document camera and we'll get going. All right, yeah, big picture, just as a reminder, we're still early into this unit. So by now, if you have not done your polynomial operations homework, which that is R4, not R3, need to get that updated, then it's going to definitely hinder you with what our trinomials doing today, because particularly the reverse FOIL, if you haven't multiplied your polynomials, then it makes it much harder to do it in reverse. Okay. So, like I said, it's really important that you have done your R4 homework for today's discussion. But that's these two topics are going to take up a good bit of time today. All right, so let's get into just a quick review. Remember, as a critical thinker, you're going to have to figure out which technique to use. We talked about this a lot last part 1 of the video, but let's just review this right quick. Remember, you should always look for a GCF first. Any of these polynomials could potentially have a GCF. If you have that, you want to factor that out first. I'll also make sure your polynomial is in descending order, because if not, that messes all our factoring techniques up. And we need these in descending order for everything to work nicely. If you have 4-term polynomial, then you use factor by grouping, which the AC method, one of its steps is to take a trinomial and turn it into a 4-term polynomial, so you can use factor by grouping. Okay, so if you like factor by grouping, you're probably going to more likely use the AC method than reverse FOIL. And then after we do our trinomials, then we'll talk about different squares that has 2 terms. That's where we're talking today, are these 2 steps. All right. Let's see, we'll come back to page 2 from a couple more examples. let's go to page 3 in the notes. And so we're going to talk about two methods today for trinomials, the reverse FOIL and the AC method. Now, often the reverse FOIL method is called guess and check. Um, I don't like that name because that kind of implies that we're randomly doing this. What I'm going to do today is try to get you to systematically do this, not randomly. Um, sometimes sometimes you can guess quickly, but if you have, it's not always quite that easy. And so if you take a systematic approach, I think it tends to make your life a little bit easier. Sometimes, the phrase, haste makes waste. This is one place where I think if you slow down, you can save yourself time in the long run. Now, why do we have two methods? And actually, there's more methods than this. I think I mentioned this before, but I don't think I've ever seen an alternate method to factor trinomials that is not one of these two methods in a different package. Okay, so like the box or diamond method, I think that's AC method. But if you have a different method to factor these trinomials and it's working for you, then by all means continue to use that method. But if your methods aren't working, then look at what we're doing today. And it's to your benefit to practice both of these in the homework. Some students like to always use reverse FOIL. Some students like to always use AC method, and that's fine. I personally like use reverse FOIL most of the time, but when they get messier, I like to use the AC method. But it's nice to know both methods. And if you don't practice them both, you don't know which one works better for you when. One of the things that both of these methods have in common is both of these methods are going to start by focusing on the leading term and the constant. Right? And then we'll deal with the middle term second. Right? It's just how they do that is different. Right. Now I've got the AC method, I got the steps written out. I don't for the reverse FOIL. But before we do either of those, I want to do a quick review. So let's multiply 2x minus 3 times x plus 7. You should recognize these type of problems. Like I said, if you've done your R4 homework, if not, that's why we're doing a quick review. Now multiply is the same basically as FOIL. And I'm going to talk about that since we're doing reverse FOIL. So how do you multiply this? Hopefully you know to fully distribute. We're going to get 2x squared plus 14x minus 3x minus 21. And then you combine your like terms. So we have 2x squared, and then that gives us plus 11x minus 21. All right. So most people like to FOIL multiply binomials. Pretty straightforward process. But if you're going this way, we're multiplying. But now what we're going to do is we're going to go backwards and we're going to factor. So this way it's multiplying, we're going to distribute. So this is why, like I said in previous video, this is why I had you do a lot of these multiply problems, because the more comfortable you are with this, the more comfortable you are going backwards. And so I wanted to point out that, when we FOIL two binomials, initially you have four terms that you multiply out. With the vast majority of the problems we're going to get, you're going to have some two-like terms to combine, and so you end up with a trinomial. If these don't combine, then you get a four-term polynomial, and that's factored by grouping. But in general, and sometimes these will cancel out, and then you'll have a binomial, because then there won't be another term. And that's when we get into difference of squares. But in general, when you're factoring a trinomial, your answer is going to be two binomials. So our goal is how do we start here and get here? And when you're doing reverse FOIL, you're using your knowledge of how all this works. But what do I mean by that is, where does that 2x squared come from? How do we get to x squared? Well, you have to do 2x times x, and that's where we get x squared. So this was that first in the FOIL. Where does that minus 21 come? Well, minus 21 came from minus 3 times plus 7. So that was the last term. So for the first term and the last term in our trinomial, there's only one multiplication that leads to those terms. Now, where does the middle term in the trinomial come from? That comes from combining the two middle terms. So that comes from the outer and the inner. So in terms of like which terms in the trinomial are more complex to get, the middle term has two contributors, so it's messier than the first term and the last term, which have only one product to get to. So that's why both the reverse FOIL method and the AC method start by focusing on the first and last terms. Then once we do some work with those, then we'll figure out the middle term. But anytime you're doing factoring a trinomial, you're kind of working on the outside, working your way in. And it's all because of how multiplying binomials, so foiling binomials works. Okay. The other thing on this before we get into the actual process is the signs of your factors. So one of the things that I see a lot of times with students is they'll be working on the numbers and just struggled and it never works. And often when that happens, it's not because of the numbers, it's because of these signs. So anytime I talk about the signs of the factors, I'm talking about we're assuming that the leading term is positive. If not, there would be a negative GCF out here. So that's why we kind of like the leading coefficient to be positive. So these will always be positive, and then we just got to worry about the second terms, whether they're positive or negative. If you get these signs wrong, you will never get the right answer. Okay, so you got to know your signs as well as the numbers. So let's look at those possibilities. I don't have a spot for this in the notes. In my intro class, I have it, but I didn't get those in my college algebra notes. So you may want to write this down somewhere so you have it to look at. So there are 4 trinomial possibilities. And so the first one, our generic trinomial is just ax squared plus bx plus c. Okay, so everything's positive. So when you're looking at your factors, what do those signs have to be to get everything positive over here? And when I say signs, again, I'm talking about like that minus and that plus. Well, if everything's positive over here, those factors both have to have positive signs. That's straightforward enough. What if we have ax squared plus bx minus c? Okay. Now, what do these binomial signs, factor signs have to be? Okay. Well, if you're looking at that and thinking plus minus, you are correct. But my question is, why are you saying plus or minus? There's a right reason to say that and a wrong reason. Okay. If you're looking at it and thinking, well, there's a plus minus there, so that's plus minus, that's the wrong reason. Okay. The fact that these are different has absolutely nothing to do with that plus. It's all about this minus. Right? And the reason it's only about this minus, remember that when you get that constant term, you're only multiplying 2 numbers to get that. So how do we get a negative 21? Well, either in this case, the 3 was negative, the 7 was positive, or it could have been reversed. But the only way you're going to multiply 2 numbers to get a negative answer is those signs have to be different. Okay. So since that is a minus c, those signs are different. It could be minus plus, didn't matter which one comes first, but the signs have to be different. So what if we have ax squared minus bx minus c? What are our signs of our binomial set to be now? Well, if you're thinking minus minus, because those are both minus, sorry, that's not it. If you think about it this way, what if you have, what if you do x minus 4 times x minus 1? Well, if you FOIL that out, in just the number part, negative 4 times negative 1 is plus 4. That's not going to give us a minus right here. So again, the only way that you're going to get a negative when you're multiplying two numbers is the signs have to be different. Now, well, whether which one's positive, which one's negative, that's when we get into the numbers, that are associated with our x's and our constants, and we'll get into that. But if you have your third term is negative, that tells you you have to have different signs. And then the last one, ax squared minus bx plus c. What do our signs of our factors have to be? So hopefully you're kind of getting onto what you're not supposed to do, and you say minus plus because that's what you see there. Again, look at that constant. We're multiplying two numbers to get a positive result. How can what do those numbers have to be? Well, they either have to be positive, positive, or negative, negative. Either result will give us a positive answer here. But if they're all positive, then everything will be positive. If that middle sign is negative, then we want negative numbers. So to get that positive C, we want either two positive, two negatives, then you look at here. So here's the key. So look here first. Sorry for my penmanship. So if that third term, which most of the time is going to be a constant, sometimes we could have two variables in there, but whatever that third term is, as long as you're in descending order, if the signs are different, sorry, if that third term is negative, the signs are different. Okay. If that third term is positive, then that tells you the signs are the same, either positive, positive, negative, negative. Then you look at that middle sign to see if they're both positive or both negative. So this is, you have to get your signs right on your factors. Doesn't matter if we're doing reverse FOIL or AC method. But if you get those signs wrong, again, you're going to be wasting a lot of time. It can be frustrating. All right. We're going to refer to that more than once. Okay. So let's start with reverse FOIL. And one thing I will say, like in general, when your trinomials have a 1 in front of the squared term, this is 1x squared, this is 1x squared, those tend to be much less messy than when we have trinomials with a number in front of the squared terms, like this 7x squared. That one's going to be a messier problem. I personally tend to do reverse FOIL on these ones that have a 1 in front of them, and then since I like to factor, I'll try reverse FOIL on this. If I can't get it very quickly, then I'll go to AC method. But the reason that these tend to be easier, or I don't like to use the word easy, but tend to be more straightforward, is if there's a 1 in front of that x squared, you're basically saying what multiplies to give me that constant that's going to add or subtract to give me the middle term. So in terms of trying to figure out the numbers in our binomials, a 1 in front of the x squared makes our life much simpler. If there is a number in front of the x squared, then we can no longer say, well, what multiplies to give me 5 is going to add or subtract to give me 34, because that 7 has to be taken into account. And so for reverse FOIL, the fact that these are more basic, that helps us use our FOIL knowledge a little bit easier. Good. All right. So what do we do for reverse FOIL? Well, step 1 for reverse FOIL is I want to make a t-table off to the side, and I want to list all the factors of my first term and all the possible factors of my second term, or sorry, of my constant. We're going to worry about the middle term later. And so what are the factors of x squared? Well, the only way I can factor x squared is 1x times 1x, or just x times x. What are all the ways that I can factor 12? Now, you might randomly be thinking 2 times 6, 3 times 4. With smaller numbers, Doing it randomly can be gonna be fine because it's a little easier to get your answers sometimes. When you get into messier numbers, and particularly when you get into more negative signs, it's helpful to not be random. So if you want to save time in the long run by spending a little bit of time to set it up correctly, this is my recommendation. Is I always like to start with one. Well, I factor 12 by 1 times 12. Then I go to 2. 2 will go into 12 6 times. Then go to 3. 3 will go to 12 4 times. And if you go in order like this, then the next number would be 4. 4 is already on my list. So I don't have to find any more factor pairs. These are all the possible factor pairs. When we get into bigger numbers, this systematic method will really come in handy. Okay, so what this tells us, why are we doing this? Well, what we're looking for is what are the possibilities for these first terms in both the binomials, and what are the possibilities for the second terms in those binomials. That is what we just listed here. So that's your first step, is list all the possible factors of your first term, list all the possible factors of your third term. Now we're going to make an educated guess. Now we know that when we factor a trinomial, it's going to be 2 binomials. So do your 2 parentheses. How are we going to get x squared? Well, the only way to get x squared is x times x. Now, this is where I put in the signs. Okay, some people like to worry about the signs, different spots. This is where I do the signs. What do the signs in those factors have to be? Well, if you look at the original trinomial, everything's positive. So that means everything has to be positive in our binomials. Okay. Now what we're doing, we need to get the last term in each binomial. Well, since there's a 1 in front of the x squared, excuse me, what we're saying is what multiplies to give us 12, that in this case is going to add to give us 8. Well, some of you may have already figured this out a long time ahead of me, but this is why I like writing it down. It's because we want that 2 and that 6, because 2 plus 6 gives us 8. Since they're both positive, then we don't have to worry about the order. If one's positive, one negative, then we got a little bit more work, and we'll talk about that in the next couple of examples. Okay. Now, remember, this is an educated guess. You're not always going to get your guess right the first time. So let's see, how do we know if this is right or not? Well, you check by FOIL. Okay. So if you FOIL this out, so x times x gives me x squared. X times 6 gives me plus 6x. 2 times x gives me plus 2x. And 2 times 6 gives me plus 12. Like terms to combine, we got x squared plus 8x plus 12, which is what we're trying to get. That means that is our answer. So if you like to FOIL, a lot of times this reverse FOIL can be pretty efficient. Again, this one's a bit more basic because the signs are all positive, which helps. But this is the basic idea. Okay, so you start with your possible factors, your first term and last term, and then we build reasonable guesses over binomials. All right. My instinct is to say, are there any questions? Fortunately, I can't get those answered right now. So remember, at any time, if you have questions, please write them down. So that way you can email me and I can address those questions. Okay, so let's do another. So now we're doing a factor x squared minus 2x minus 99. So come off the side, do a t-table for the first term, which is x squared, and the last term, which is 99. Now notice I'm not worrying about the negative, because I'm going to worry about the negative once we make our guess. Plus, I think it's a little bit less messy that way. Now we factor these. So x squared is only x times x. Now 99, again, let's go in order. The 1 and 99. So it's not even, so 2 is not going to go into it. So 3, and again, don't forget you do have calculators, so if you need them, feel free to use them. It's not a bad thing. Say 4 is not going to go into it. So no even number is going to go into it. 5 is not going to go into it. Then in 5 is 0. 6 is an even number. 7. You get a decimal number, so 7 is not a factor. 8. 9 is going to go into it 11 times. 10 is not going to go into it because then into 0. So then 11 would be the next number I check. 11's on my list, so I've got all the possible factor pairs. So this is why I like to do it in order. I mean, this is relatively clean because there's only 3 possible factor pairs. It's not always, we can, especially once you get into the stuff that requires the AC method, and you get a lot of options here. All right, so what do we do with all this? So we're going to make an educated guess. So we're going to have 2 binomials. Right. Now, to get x squared, we have to have x times x. Now, what do the signs have to be? Remember, look at the third term first. That's negative. So what's the only way that I can multiply 2 numbers to get a negative? A positive and negative. All right. And now, since there's a 1 in front of the x squared, we're basically saying what's going to multiply to give me 99. It's going to actually, in this case, since they're different, we're subtracting to get 2. If they're the same, both positive or both negative, then we're adding to get that number. So if you look at your factor pairs, which ones we want to get 2? And if you have them written out, it makes this a little bit more straightforward. Now here's the question, which one's positive, which one's negative? Now, the general idea is like if that, the bigger one needs to be what matches that sign, as long as there's 1 in front of here. If there was a number in front of there, it's more complicated. And since that's negative, my first instinct is 11 needs to be negative. I want to do this the wrong way and show you how that's helpful. Let's say I'm going to do plus 11 minus 9. Well, please check these, because again, that was an educated guess. We haven't guaranteed that we did it right. So if we blow this out, x times x is x squared, and then minus 9x plus 11x, and minus 99, binary like terms, you get x squared plus 2x minus 99. And negative 9 plus 11 is positive 2. So what is the issue here? Well, the issue is that's positive, supposed to be negative. So we have the wrong answer. Particularly on a test, one thing I see students do a lot of times is they erase their work if it's not right. If it's on a test or even in the homework, if you get a wrong answer, just cross through it. So that way you can see what you've tried before. Sometimes I see students do the same one over and over because they kind of get lost in the process. If you cross it out, you can see that what you've done before. However, this isn't a bad result because we want a negative 2, we got a positive 2. So this is what I call the right number, wrong sign. That means we're close to the answer. If that was a 7 or an 8 or a 20, then that's definitely a wrong number. So we're not even in the ballpark yet. The nice thing about having the right sign, wrong number is we basically just need to swap this from a positive to a negative. Well, how do we do that? We swap these signs. So we need to swap these signs. So now our next guess, which many of you have already done already, but again, like I said, I wanted to do it the wrong way because I think this is educational. So instead of plus 11, I want minus 11, and then x plus 9. And then when you check it, which in this case, I'm just going to check the middle terms. So we're going to get plus 9x minus 11x, which is minus 2x, which is what we want. So our answer is that x minus 11, x plus 9. That is how you factor x squared minus 2x minus 99. All right. So hopefully you're kind of seeing the benefit of this systematic approach. And again, as long as there's a 1 for the x squared, it tends to make our life a little bit easier. All right. Let's see. I want to do 32 both ways, so let's do that one next. Run on my paper. So by reverse FOIL, we're going to factor 7x squared plus 34x minus 5. Okay. So I'm going to do my D table. We're going to do factors of 7x squared and the minus 5. Yeah. Well, the only way to get 7x squared to factor it is 7x times 1x. The only way to factor 5 is 1 and 5. Okay. So for me, this isn't too bad of a problem to do by reverse FOIL because there's only one option for each one. It's not uncommon for once you start doing this to have multiple ways to factor your squared term, multiple ways to factor your constant. When that happens, it doesn't matter if you do reverse FOIL or AC method, those can get messy. This one's a relatively short one, so let's go through it. All right, so we need to make an educated guess on how to factor this. Well, we know we need two binomials. So what is the way that we're going to factor 7x squared? Well, it's only 7 and x and 1x, which we tend to not put the 1, so just 7x and x. What do the signs have to be? How do we multiply two numbers to get a negative? They have to be positive and negative. Now, in this case, so these are a little bit more complicated. We got these numbers from, so I'm just going to put positive or negative. And then as we're going through this, if that doesn't work, then I know I'm making educated guesses. I'm going to check to see if it works. If not, then we'll fix it. Yeah. All right. Then what do you do? Well, to get the 5, we need a 1 and a 5. And again, I'm just going to, that's the order they came in, so I'm going to throw them in. So is this right? So you check it by FOIL. So we have 7x squared minus 35x plus x, or plus 1x if you want, minus 5. Combine like terms. We get 7x squared minus 34x minus 5. So is that correct? Close. We got minus 34x, we want plus 34x. So that did not work. So again, what that tells me is that we have, like we had before, we had the right number, the wrong sign. So that means we just need to swap those signs. Now we're swapping the signs, not the numbers. So it'd be 7x minus 1 and x plus 5. We check that. Again, I'm just going to check the outer and the inner. So we're going to get plus 35x minus 1x, which is plus 34x, which is what we want. That's good. So there's our answer. Okay, so 7x minus 1 times x plus 5. Okay. Where this gets messy is what if we didn't have the right number wrong sign? Now, once we get the right answer and we check it, we're done. We don't have to go anything more. I want to show you a wronger answer and how to deal with it. So what if we, in our first guess, had not put the 1 with the 7 and the 5 with the x? What if we had put 7x plus 5 and x minus 1? So basically, one thing you're gonna have, something you're gonna have to do with this reverse FOIL for these is we're gonna have to swap these numbers sometimes. Now notice up here for these that have x 1x squared, you never have to swap those signs because or those numbers, because you're still multiplying 11 times 1x or 11 times 1x, no matter where that 11 is, because there's a 1 in front of both of those x's. So all that matters with that 11 is the sign. But once you start putting numbers in front of your x squared, that number, which binomial it goes into, changes the problem. And so if we check this, so now we solve our 7x squared. Now we have minus 7x plus 5x, and then minus 5. We get 7x squared minus 2x minus 5. So we have minus 2x, we want plus 34x. So the bigger problem here is not the sign, it's that number is not 34. So it's not even close. And so since it's not even close, I don't want the 5 with the 7 and the 1 with the x. And so you have to get in the habit of flip-flopping those numbers and put the 1 with the 7 and the x with the 5. So for some people, this part of it, if you don't get your guess right the first time, how to get the other guesses can get complicated. And I understand that, but that's why we're also teaching the AC method. One thing I do want to point out is sometimes you're factoring over here. There's a lot more possibilities. So let me just kind of show you. Let's say we're doing some trinomial. What do I want? 20x squared minus 3x plus 30. I have no idea if that factors. We're not going to factor this. I just want to show you this part of it over here. I would not do this with reverse flow. I would do this with AC method, which is still going to get complicated over here, but it takes a lot of guesswork out. So how do you factor 20x squared? Well, it could be 1x and 20x, 2x and 10x, 3 doesn't go to it, 4x and 5x, and then 5 is the next one on my list. So we're good. How can you factor 30? 1 and 30, 2 and 15, 3 and 10, 4 doesn't go into it, 5 and 6, and then 6 is the next one on my list. So those are all my possible factor pairs. Okay. So you have a lot of possible factor pairs to check here. And the reason being is like we could use the 4x and the 5x. It could be with the 5 and the 6. We could have the 4x, and you could flip-flop those. You could have the 4x and the 5x with 3 and the 10. And then you could flip-flop the 3 and the 10. You could have the 4x and the 5x with the 2 and the 15. And then flip-flop the 2 and the 15. You could have the 4x and the 5x with the 1 and the 30. And then again, flip-flop the 1 and the 30. So that's right there is 4, and then flip-flop them. That's 8 possibilities. Now, what about the signs? Well, that's a plus. So what does that tell us? It tells us the signs are the same. They're either positive, positive, or negative, negative. That tells us they're negative. So in this case, they're both negative. So we actually only have 8 possibilities that we had to check. Because once you swap those, I'm not going to write them all out, but you can. So there's 2 each one of these has 2 possibilities with it. So that's 8 possibilities just for the 4x and the 5x. So there's 8 more possibilities with the 2x and the 10x, 8 more possibilities there. So there's 24 possible ways that you can make a reasonable guess as how to factor that. This is where, people tend to not like reverse flow, and I don't blame them. Now, one thing I will say is and again, I have no idea if this factors. I randomly made this up. I doubt if it factors. If it was me, if I was doing something like this reverse FOIL, I would start here, start at the bottom. I just know how, the people that write these problems, they often choose those numbers that are closer together. That are, if you're doing this in systematic order like this, those are the ones that are most likely going to work. Okay. This, let's see here. Yeah, why is it? This does not factor because that 3 doesn't work. That 3 needs to be something different. So I'm not going to go further, but I would start here rather than like the 2x and the 10x. The only time I would ever start like up here if this was a really big number. This is a really big number, then there's a good chance that we're multiplying bigger numbers. This is usually going to be relatively small, so then you want to start with the relatively small numbers. Okay. So this is where reverse FOIL can get messy. If you're systematic in how you do your guesses, you can still do this reverse FOIL. But this is like I said, for a lot of people, that's not the preferred way once we get into these messy numbers when there's a number in front of the x squared and you have a lot of possible factors. Okay. So that is that. All right, so let's talk about AC method. So it's an alternate alternative method to deal that is, to me, is definitely more dealing with this. I think the AC method is a little overkill if there's a 1 in front of the x squared, because then you're just like, what multiplies to give me this is going to abstract to give me this. But for a lot of people, doing the same method every single time works best for them. And so more power to you if you like the AC method. Okay. So what does the AC method look like? And so I do have the steps here on page 3. But no, both methods still start with the first term and the last term. Just what we're going to do with it is different. The reason it gets its AC method is the generic trinomial that we factor and is ax squared plus bx plus c. So when you see AC, anytime you have two letters next to another, that means multiply. So we're literally, the AC method is literally named, and we're multiplying the first term times the last term. We're doing A times C. The variable's going to tag along as part of it, but we're literally, that's AC method is A times C. And so what we're going to do is on our table, instead of having the first column being the first term, that first column is now going to be our AC product. So whatever we get when we multiply the first term and the last term, that's what's going to go here. What are we going to do with that? Well, we're going to list all the factors of that product. So just like we were doing in our tables here, we're going to list all the possible factors. But what we're going to do now, instead of listing the possible factors of the last one, we're going to try to get that middle term. And so that is what's going to go in the second column. Then once we do that, and we're going to do some examples here, but once we figure out how to add or subtract to get that, what we're going to do is rewrite that middle term with the two terms we just found. So we're going to take that middle term and split it up into two terms. Once you do that, you have 1, 2, 3, 4 terms. So then we do factor by grouping. So if you like factor by grouping, like I said, you're probably going to prefer the AC method. This page is a bit messy, so let's go to the side page. So I know we've already done this problem with reverse FOIL. Let's do the same problem with the AC method, just so we can kind of compare and contrast. We're factoring 7x squared plus 34x minus 5. So we're going to go off the side, do a t-chart. And so that first column is the AC. So AC is the first term, times the last term. Sometimes, I see some people put in the positive or negative, but that makes this messy. Again, I like to do the positive and negative a little bit later over here. I just think it makes it a little bit less to keep track of. And so 7x times 5, 7 times 5 is 35, x squared. Now what we want in that second column is the middle term. So we want a plus 34x. All right. So that's how we start. So we're not doing columns for the first term and the last term. We're doing columns for the product of the first term and the last term. And then we're going to try to, we're not factoring this middle term. That's just what we want for adding and subtracting. So how can you factor a 35x squared? Well, 1x and 35x. 2 doesn't go into it. 3, 4, 5. So just 5x and 7x. 6 doesn't go into it. 7's already in the list. So there's only two ways to factor 35. 1 and 35, 5 and 7. Okay. That is the same base thing we've been doing. Instead of doing one specific number, we're factoring product. Now, how do we get, by adding or subtracting one of these pairs, how do we get plus 34x? Well, it's not 7 and 5 because if we add them, we get 12. If we subtract them, we get 2. 35 and 1. Well, how do we get a plus 35? Or sorry, plus 34? We need to do plus 35x minus 1x. And make sure to put that plus there because we're going to need it in the next step. If you wanted, you could say minus 1x plus 35x. You want to keep those in the order. The order doesn't really matter. Sometimes you don't want, because factor by grouping, we don't want, this is going to be like the middle term. We don't want that to be negative. But I'm going to assume that that's something that you can deal with once you kind of practice factor by grouping. So put that in whatever order makes sense to you. Now here's a question. This is where I check my signs. Does it make sense that we have one positive number and one negative number? If you come back to your original trinomial, that third term is negative. The only way that I can get a negative number by multiplying two numbers is if one's positive and one's negative. And that's an important question to ask because sometimes when these products get big and you have a lot of possible factors, sometimes there's more than one way to get that middle sum. But if there's more than one way, it's not going to be the same signs. They're either going to be both negative, one's positive, one negative, or both addition. So you got to make sure that the signs make sense based on the signs that you're trying to. All right. That is the first part of the AC method. Again, that's where the AC method gets its name, because we're doing A times C factoring. So what do we do with that 35x minus 1x? You split that middle term into those two terms you just found. So plus 35x. Now, and keep the minus 1 for now. We don't normally put like final answers, but I think that'll help with the factoring. Okay. This is all step 1 and 2. So rewriting this is step 3. So step 4 is now do factor by group. So how do we do factor by grouping? Hopefully you've watched the first part of this factoring video. So we're going to do GCF factorings on the first pair and the last pair. So what's common there? They both have an X. 7 goes into both of them. So 7x is our GCF. Divide that by 7x, we have an X left. 35x divided by 7x gives us a plus 5. How do we, what's the GCF for the last two? This is where you have to be careful. Remember, if that sign's negative, you got to bring it down. So what's the GCF of 1x minus 5? If you're thinking there isn't one, then I'm wondering if you didn't watch my factor by grouping part of the last video. If there is no GCF, it is 1 because 1 is the biggest thing that will divide them. 1 will always go into everything. But because that negative, we're actually factoring a negative 1 as a GCF. So if you divide both of those by negative, negative divided by negative is a positive. So that's just x. And then negative 5 divided by negative 1 is plus 5. And remember, at this point, if these are inside parentheses are not the same, stop because something is wrong. The most common mistake with factor by grouping is when this is negative. A lot of people like here would put minus 5 because they're doing negative 5 divided by 1 in their head, but you're supposed to be dividing by negative 1. And so If you put a -5 there, -1 times -5 would be +5. So if these are not the same, distribute these back out and see what your mistake is and get it fixed. Once they're fixed, once they're the same, we'll go straight to the answer. So we're factoring a trinomial, so we have two binomials. Remember, what's inside is half the answer. What's outside is the other half. So x plus 5 times 7x minus 1, or you could flip-flop them because it does not matter what order you must find in. And just to verify, so before we had 7x minus 1, x plus 5. It was 7x minus 1, x plus 5, same answer. But this is the core of the AC method, is figuring out how to convert that into two parts that you can do factor by grouping. Now, there's a lot of ways, a lot of ways you could split up 34. You could do like plus 33 plus 1 to get plus 34, but 33 and 1 have nothing to do with those numbers, so that wouldn't help you. That's why you have to start with this product so that you can start with these possible factors that leads you to that middle term. All right. More examples. Um, Looking here, number 11. This is because there's several here that we could do AC method on, like x squared minus x minus 35, x squared plus 4x minus 60. You could definitely do AC method on those. But again, like the AC method on here would be just 1 times 35. So then you're just looking for the factors of 35. AC method is pretty kind of a little bit overkill on this, but I want to do, since we're working together, I want to do some of the messier ones. Okay, so let's try number 11. We're going to factor 15z squared plus 8z minus 16. This is number 11 from page 2. All right, let's do this by AC method. Do your little table, or AC, and then what we want. Well, AC means the first term times the last term. So 15 times 16 is 240. 240 z squared, and then we want a positive 8z. Now, when you got numbers like this, if we did this reverse FOIL, this would be a messy problem. This is going to be messy with AC method. But I think the type of messiness is less guesswork with the AC method. But again, it's up to what works best for you. And then if you notice, if you start randomly guessing the possible factors of 240, how many are there? And like, what are the odds you're going to randomly guess the right one? So here's what I do. Start with 1. So 1z, 240z. 2z, and then 240 divided by 2 is 120. Now we could go 3, 4, 5, keep going that way, but here's something I do to kind of save time. Are we anywhere close to getting an 8z? Well, 2 and 120, if we abstract them, is either 122 or 118. So we're not anywhere close to 8. But sometimes what I'll do is I'll skip a little bit. I'll save space because I might want to come back to them. So when I look at, like, when I see the 240, since it ends in 0, I like 10. So let's try 10 and 24. Well, if you abstract them, add them as 34, you subtract them as 14, which is not 8, but you can see we're a lot closer than we were before. And so since we're closer, I don't think we need 3, 5, 6, all those. So let's just start with 10 and keep going. And so does 11 go into 240? Nope, we get a decimal. 240 divided by 12 is 20. Now, notice we're trying to get plus 8z. 20 minus 12 gives me 8z. So if we, so how do we get that 8z? We need a minus 12z plus 20z. Does it make sense that we have opposite signs? Well, we've got a minus 16. The only way we multiply two numbers, you get negatives. If one's positive, one negative. So this is what we want. If we don't need to keep going, I don't need to back up. I found how to get a positive 8z. And then notice that if you put that negative first, the nice thing about putting that negative first, well, the next step is you go back to the original trinomial, split that middle term up into two terms. So now we have 15z squared minus 12z plus 20z minus 16. If you notice, that middle term is now positive, so we don't have to worry about the negative GCF. So a lot of times I like to, if I have a positive and negative, I like to have my negative first to make the factor by grouping a little bit easier. So now we're going to do our factor by grouping. So what's common to 15z squared? They both have a z, and number-wise is 3. So we divide that by 3, we get 5. Z squared divided by z is z. Negative 12 divided by 3 is minus 4. Z divided by z is 1. And now, since that middle sign is positive, we'll bring down just a positive GCF. Biggest thing that goes into 20 and 16 is 4. Divide both those by 4, we get 5z minus 4. And if you notice, inside the parentheses is the same, so we're good. So now we can go to the answer. So we get, and again, some people like to put the outside stuff first. If you did that, it would be 3z plus 4. And then the second binomial would be the inside, which is 5z minus 4, or you can flip-flop those. If you tried to do this with reverse FOIL, you would have a lot of possibilities to check. But again, remember I said that if you check the factors that are a little bit closer together, I'll find that page. Like this is one where you would have ended up something like this. But if you try those ones that are close together, notice 3 and 5 is the smallest numbers you can do for 15. 4 and 4 are the closest numbers you can do for 16. So even though this is kind of messy, with reverse FOIL, the way they wrote the problem, you probably got lucky with reverse FOIL, if that's your cup of tea. And again, how do we know this is right? FOIL it out. So 3z times 5z, that gives us the 15z squared. 3z minus 4 gives us minus 12 plus 20, which is plus 8. And then plus 4 minus times minus 4 is minus 16. All right. So again, I highly recommend that as you're doing the homework for these trinomials, try both reverse FOIL and AC method so you have an idea of which one you prefer. And like I said, for me, if there's a 1 in front of it, I tend to do reverse FOIL. You're essentially saying what multiplies to give me the constant that's going to add or subtract, give me that. So to me, the AC method's a little bit of overkill for that. But this is one where, even though I like reverse FOIL, my natural inclination is just go straight to AC method. So I don't have to worry about all the possibilities of guessing on my binomials. But again, if you're not systematic in this could have been what really trips you up on the AC method. So please get in the habit of going in order. And like I said, I made an educated guess to skip just because I knew that these were nowhere close to that positive 8, and 10 was a natural number for me. And then like definitely closer, so then you kind of start again. So I didn't ignore those. I just had to use my number system to say that they probably weren't going to work. All right, so that is AC method. So before we do difference of squares, let's see. Let's go back to number 8 on the page. We have 16y squared plus 72y minus 40. All right, that's a trinomial. So what do you want to do to factor? Reverse FOIL or AC method? I don't know about you, but when there's a big number in front of this y squared, I tend to go to AC method. But when you do 16 times 40, that's 640. How many possible ways can you factor 640? I don't know about you, but that sounds like there's a lot of ways. And if you try to do this reverse FOIL, like how many different ways could you factor 16? How many different ways could you factor 40? This seems like a very messy problem. So are we missing anything here? Well, hopefully you're saying yes. Remember when I said you should always look for GCS first? I did emphasize that on the last couple of examples because I knew there wasn't a GCF and I didn't want to like distract you too much. But these are problems where the messier they look, the more likely there is a GCF. When I look at that, the first thing, one, I was like, those are big numbers. Ooh, I even want to back off on the factoring, but they're all even. So I know for sure that two will go into them. The question is there anything bigger? So start with 16. 16 won't go into 40, so 16 doesn't work. Is there anything between 16 and 2 that will go into them? Well, I know 4 will go into 16 and 40. 72 divided by 4 is 18. Is 4 the biggest number? Remember this technique we talked about? If you think you have a GCF, do your factor tree with that number. So 16 is 4 times 4. 72 is 4 times 18. 40 is 4 times 10. So if you do your factor first factor with your GCF, so there is our common factor. Is there anything else common? Well, look at what you have left. Is there anything common with 4, 18, and 10? Yes, they're all even, so they're all divisible by 2. Should have left more room here. Sorry. So, so if we do that, we have 2 times 2. Here, 19 will be 2 times 9. 10 is 2 times 5. So if you notice, so not only do we have a 4 in common in all of them, we also have a 2. Is there anything else common? Now, well, 16 has a 2 left over. 2 doesn't go to 9. 2 doesn't go to 5. So, 5 doesn't go to 9. So there are no other common factors. But we do know that GCF has 2 common factors, 4 and 2. So you multiply them. So the GCF is 8. So 8 is the biggest number that goes into all 3 of those. So that's step 1, is factor out your GCF. You can't factor it out if you're not looking for it. So what we're going to do is we know 8 is the GCF, and so we divide each of these by 8. So 8 divided, yes, that's 2y squared. 72 divided by 8 is 9. Negative 40 divided by 8 is minus 5. All right. Now notice this is y squared, y, and a number. So this tells, when you have a trinomial like this and the highest exponent is 2, factor again. If that was like 2y to the third, it's not going to factor again. So this is where you have to look again. And again, typically these problems are going to be towards the end of the homework. or on the test, this would be like you have like a factoring section on the test. This would be like the last factoring problem because I do kind of like to put these in order of difficulty. So here's a question. Would you rather factor this trinomial or this trinomial? Yeah. I don't know about you. I'd rather factor this trinomial. I don't know how to factor it. All right. I've only done two examples for AC method. So I'm going to do AC method. If you prefer um, reverse FOIL, then by all means do so. This one's not so bad with reverse FOIL because 2 is only 1 and 2, 5 is only 1 and 5. So there's, the possibilities are limited, so you don't have to make as many guesses. But I'm going to do AC method. So I'm going to do 2y squared times 5. Gives me 10y squared. And what we want is the middle term of plus 9y. How do we factor 10? Well, 1y, 10y, 2y, and 5y. So how do we get plus 9 out of that? Well, minus 1y plus 10y. Does it make sense that our signs are different? Yes, because we have a negative third term. So what do we do with that? Split that middle term. 2y squared minus 1y. It's 10y minus 5. Now we're going to do our factor by grouping. Y is the only thing common to the first two. That gives me 2y minus 1. We bring down the signs, so that's plus. 2 is the GCF there. Divide both of those. Oh. You ever notice how sometimes your subconscious gets ahead of you? Like, where did that 2 come from? Well, in my subconscious told me that the GCF was 5, and then 10 divided by 5 is 2. So my brain, sometimes your brain gets ahead of you. This is what happens when you get in a hurry. So the GCF, sorry, is 5, not 2. And the reason I knew it was wrong is because over here, if I would have divided that by 2, I would have not got 1. And these are supposed to be the same. So 10y divided by 5 is 2y. Negative 5 divided by positive 5 is minus 1. Those are the same. So now that factors to 2y minus 1, and then y plus 5. So is this our answer? So if we multiply that, are we going to get this? Definitely not, because 2y times y is 2y squared, not 16y squared. So what happened? Don't forget your GCF. So it's 8 times 2y minus 1 times y plus 5. So that GCF has to be part of the answer. That's a very common mistake, is people don't put the GCF in the problem or in the answer, even though they find it. So yeah, so like I said, if it looks very messy and it looks hard to factor, there's a good chance you're overlooking a GCF. And you want to factor that GCF out first, because if you don't, we could have factored this, the AC method or reverse FOIL. It would have been way messier than this. And the problem is, when we got down to our answer, there would have been GCFs in these binomials. And most people, if you don't find the GCF at the beginning, you don't look for the GCF at the end. And so you'd still miss the problem. So just always be in the habit of looking for a GCF first, and just, to me, that's sort of a red flag. The messier something looks, the more likely there is to be a GCF. All right. So again, I wish I could ask for questions, but I wouldn't hear you. So please email any questions you have. All that was for trinomials. Yeah, I know but we're close to being done, so just bear with me. So that was 3 terms. Now we have to go back to difference of squares. Now for the difference of squares, I want to do a quick FOIL problem again. So I want you to multiply for me 3x minus 5 times 3x plus 5. Let's see what happens. I'm getting 9x squared plus 15x minus 15x minus 25. And so you get plus 15 minus 15. So those cancel out. You get 9x squared minus 25. All right, so this is the classic difference of square patterns. Why do we call it difference of squares? In math, we are extremely literal typically on how we name things. So it's a difference because it's two things subtracted. So a difference of squares always has to be a binomial, never a trinomial, never four terms, only a binomial. And the reason we call it squared or difference of squares, how do you get 25? 5 times 5. You squared 5. How did you get 9x squared? You did 3x times 3x. So we squared 3x. So that is why this is a difference of squares. So this has a very distinct pattern. So if you have x squared minus, don't need parentheses, x squared minus y squared, the way that's always going to factor is x plus y times x minus y, where that x and the y are what's being squared. And why do you have to have the signs that are different? Well, think of this as a trinomial without a middle term. Think of this, this would be like x squared plus 0 minus y squared, because those middle terms cancel out. So how do you get a negative result when you're multiplying? Signs have to be different. But once you do this a few times, this is a pretty straightforward pattern. So I kind of like the difference of squares factoring because it's way less messy than a trinomials. But here's the key idea. So do you have something squared minus something squared? You know, if it's not a difference, it can't be a difference of squares. If you can't find the two things that are being squared to get those two terms, then you can't do difference of squares. But if you can find what's being squared to get those terms up here, you've done the bulk of the work of difference of squares, because once you find them, whatever is squared to get the first term goes first in your binomials. Whatever is squared to get your second term goes second in your binomials, and then you do plus or minus plus, your choice. And so this is where the bulk of the work is for difference of squares problems. Oh, so let's see. I said 9's a different squares. I want to come back to that one. It's a little bit different. Let's do 16 first. Sorry, 21. That's 16. We're factoring 16x squared minus 49y squared. So is this a difference of squares? Well, the reason you need to look at that, it's a binomial. What are the only two techniques that we have to factor binomials? Either a GCF or a difference of squares. There's no variable the same. There's no common factor of 16 and 49, so this is not a GCF problem. So if it's going to factor, it's going to be a difference of squares. So here's the key idea. Is this something squared minus something squared? So what do you square to get 16x squared? Well, 4 times 4 gives you 16. X times x gives you x squared. What about 49? Parentheses there. 7 times 7 gives you 49. And then y times y gives you y squared. So yes, this is a difference of squares. So since it's a difference of squares, we go straight to the pattern. We're going to have our two binomials. How do we get 16x squared? 4x times 4x. How do we get 49y squared? 7y times 7y. And then what do the signs have to be to get the negative? They have to be different. So plus minus, or if you prefer, minus plus. So when you're doing difference of squares, the binomials will be the same except that middle sign. Because if you look at it, you get 16x squared, then 4x times, that gives you minus 28xy. That gives you plus 28xy. Those middle terms cancel out. So the only way you're gonna get those middle terms to cancel out, these have to be the same and the signs have to be different. That is your difference of squares. Okay. So let's do another. Everybody loves fractions, I know. So I like the instructor to me loves 27. So let's do x squared minus 25 over 81. We said from last time that's a difference of squares. So let's prove it. So is this something squared minus something squared? Well, it's a difference. We've met the minimum amount there. So what do we square to get x squared? Well, x times x, easy enough. What do we square to get 25 over 81? Back, put your calculator down. What do what squares gives us 25? It's 5. What do we square to get 81? Is 9. So that's a fraction. So yes, we can square something, get both of those. So that's a difference of squares. So how does this factor? Well, how do we get x squared? X times x. How do we get 25 over 81? Well, 5 ninths times 5 ninths. And then what do the signs have to be? One of each. There you go. Okay. Let's do a little bit messier one. So number 9 is m to the 12th minus z squared. In our last video, we said that's a difference of squares, but let's see why it is. Wow. So again, the key idea is this something squared minus something squared. I'll do the hard one. There we go. Z times z is z squared. What about m to the 12th? Is that something squared? This is where, from years of experience in the classroom, a lot of people are going to say no. Some people might see this a little bit quicker, but I'm telling you, this actually is something squared. And if you're thinking, well, there's no number squared that's going to give me 12, well, you're correct there. But remember, we're dealing with exponents. Let me give you a little hint. You remember what we do if we have a variable with an exponent raised to an exponent? For example, if we had x to the 4th to the 5th power. Well, it turns out we have power raised to power, you're multiplying. So x to the 4 to the 5th, 4 times 5 would be x to the 20th. So when we're trying to square a variable, we want that exponent, we're basically multiplying by 2. So what multiplies by 2 to give us 12? 6. So 6 times 2 does give us m to the 12th. So actually, yes, this is a difference of squares. So how does this factor? Well, to get m to the 12th, we're going to do m to the 6th times m to the 6th. To get z squared, we do z times z. And what the signs have to be, one of each, plus minus, minus plus, your choice. Okay. So even though it doesn't look like it, if your exponents are on your variables are even, you're actually can square. If we were looking for cubes, which we're not in this class, then you need multiples of 3, that sort of thing. All right. These are a little bit messier. I like for homework, the test questions, difference of squares. A little bit more of where am I at? A little bit more of this speed or a little bit smaller. Let's do one more of these, and then we'll check MATLAB and see if there's anything I've missed. So I want to do, where is it? Number 13. So number 13, that was one back when we were identifying it, it says a difference of squares, even though it's cubic, and so it doesn't look like it. So let's see why that's actually a difference of squares. We're factoring 9a cubed minus 64a. Why are we even looking at difference of squares? Because it's a binomial and it's a difference. So if we try it, is this something squared minus something squared? Well, the 9 and the 64 are, because 3 times 3 is 9, 8 times 8 is 64. But the problem is, we can't square something, get a cubed, or like we square something, we're not going to get a to the first. So this is not a difference of squares. But what are you supposed to always look for first? Always look for a GCF. So if something is not factoring like it should, but it almost looks like a difference of squares because you got 964, then again, just like with that messy trinomial we did earlier with like the 16y squared, if it looks like it can factor, but it's not, there's probably a GCF. So what's common to both of those? Number wise, nothing, because nine's not there's nothing between 9 and 64, but they both have an A. So when you factor that A out, what do you have left? Well, you divide both of those by A. So 9a cubed divided by A is 9a squared. And then when you divide A by A, it goes to 1. And so now, anytime you factor out a GCF, is this a difference of squares? So again, we're getting that squared term. So again, I'm definitely checking to see if it'll factor again. So is this something squared minus something squared? Well, how do you get 9a squared? 3a times 3a. How do you get 64? 8 times 8. So yes, this factors as a difference of squares. Switch two binomials. So how does it factor? Hopefully you're getting the hang of this. So it's going to be 3a times 3a, and it's 8 times 8. Signs are different. Are we done? Don't forget your GCF. All right. So again, when you get towards the end of that homework, for the R5 homework, you're going to have some of these problems that are going to have two factoring techniques. It's almost always a GCF and then either a trinomial or a difference of squares. Sometimes you might see difference of squares, like two different squares. We could go real into depth in here, but we're doing more like a gen ed level college algebra as opposed to like everybody going to calculus. So we're not going to get too messy into that. But this is something you should always be looking for a GCF and a factoring problem, particularly if you're having trouble factoring, you might be missing the GCF. All right, I have one last problem to look at here before we do MATLAB. This is not on the page. Let's factor x squared minus or plus, sorry, 36. How are we going to factor it? Well, it's a binomial, so we're not using factor by grouping or trinomial methods. There's no GCF. So is this something squared minus something squared? Hopefully, give them a big no here. And why not? Not because of the x squared and 36, but because it's a plus, not a minus. So this is not a difference of squares. This is what we call a sum of squares. Now notice we didn't have a pattern for sum of squares. Our pattern was only for difference of squares. All right, so let's do some common sense here. Let's go back to like reverse Boyle and let's make some guesses. So if you had to make a guess on how you would factor x squared plus 36, what would you want to try? Well, we know we need x and x. Well, we know 36 is 6 squared, so let's try the 6 and the 6. And then it's all positive. So I think x plus 6 is that's usually my first guess I get. So does this work? Well, if you FOIL it out, get x squared plus 6x plus 6x plus 36. So what's the problem? These do not cancel out our middle terms. So this doesn't work. Any other guesses? How about x minus 6, x minus 6? That's usually the second guess I get. Well, if we check it, we get x squared minus 6x minus 6x plus 36. Here's where we have to be careful. Don't cancel those out because they're both negative. So that's going to be x squared minus 12x plus 36. You don't want that minus 12x, so that's not going to work. Now, often what I get for the third guess is x plus 6, x minus 6. Okay, so what happens here? Get x squared minus 6x plus 6x. So those middle terms do cancel out, so we're good, but what's the problem? Well, we get plus times negative, so we get a minus 36. But we're still not working because we need a plus. All right. And then there's no other reasonable answer or reasonable guesses here. We've went through the reasonable guesses. And so the problem with the sum of squares is the only way that you can get these middle terms to cancel out is the signs have to be different. Because if they're both negative or both positive, those middle terms do not go away. But once you make the signs different, then you're getting a difference of squares, not a sum of squares. So sum of squares, the answer on factoring that, it does not factor. So this is the one place I would give you a prime factoring problem, is a sum of squares. You got to know that there's a big difference between sum of squares versus difference of squares. There's a reason we call it a difference of squares. Okay. That's the main thing for difference of squares. All right. Let's jump into MyMathLab right quick just to see if there's anything that I missed. Yeah, when I go out there, just remember, like this is one of the bigger um, this is one of the bigger concepts for test one, like being able to do the quadratic formula, being able to solve linear equations, and factoring are like the three big topics here. So if you're struggling with any of this factoring, please let me know. If you can get to campus, we have some tutoring in the STEM lab. I don't know if students got that information. I'll have to post that in Blackboard. In the afternoons, like after lunch, I'll either be in my office here in the Reed Center, room 102, The STEM lab is in the middle of the building, 114. So I can either tutor in there or in here. The other place that we get on-campus tutoring, there's also other tutors in the STEM lab. I don't know their hours. But we have like 8 or 9 computers in there. You can come in there and work. Um, the other place to get tutoring is over in the Ollie Center in the ARC, the ARC Testing Center. Ms. Being is an awesome tutor. Unfortunately, she has to also run the testing center, so she can't tutor 100% of the time. But when she's not running testing, she's doing tutoring for us. And she's got normal business hours like 8 to 4. So if you can get her there when she's not testing, she can also help you with all of this. Like I said, she's an excellent tutor. She used to be over in the STEM lab, but then we had to give her like 2 jobs, and we kind of lost her for 100% tutoring. All right, and so in the homework, like though I think it was up through 8 was yeah. So the trinomials. I might make sure I'm sharing the right screen since I've changed. Sometimes it swaps, keeps with it keeps up with me, sometimes it doesn't. Okay, so if you start with number 8 in the R5 homework, that's your first trinomial. Um, this has a 1 in front of it. They're all positives. That's a pretty straightforward to me, a straightforward reverse flow problem. You're basically saying what multiplies to give me 21. That's going to add to give me 10. Well, 21 is 7 times 3. 7 plus 3 is 10. There you go. Notice that this one says A, you know, it has an answer box, and B, is it prime? Some of these have that on there. To me, that is prime is a red herring. And the only time you should say anything is prime that I'm going to give you that's going to be a sum of squares. If you start randomly making polynomials, there's going to be a good chance that they're prime. These are not random polynomials. These are designed um, to factor, but they're kind of covering their bases on some of these by having that choice. So you should, especially on the test, I'm not going to give you a prime polynomial on the test. Everything I say to factor on the test will factor. So you have several of these. This one has some minus signs, so you got to be a little bit more careful. My number 12 has 6x squared plus 5x plus 1. So this does have a number in front of the x squared, but since the constant is 1, to me that's still sort of reverse FOIL. Just now your options are with the x squared. You can do that reverse FOIL AC method. Again, I highly recommend that you try both of those methods as you're going through the homework. That way you know. Now notice that, let's see, like here, let's see, this one gets a little messy, but 2 doesn't go into 3. So this is not a GCF problem. So you still have to, do your normal AC method. Then, we get into difference of squares. They start kind of messy, or they start really basic, and then get a little bit messier as you go. Now notice that after the different squares, then there's 3 more problems that go back to trinomials. That's a good hint that we're now throwing GCF plus another technique. So if you look at this one, there's a 2 that goes into, they're all even. So there's a GCF of 2. Factor that out, and then factor your trinomial. This one has something bigger. Anytime you see these variables that have exponents bigger than 2, there's a GCF there of y squared. Factor that out first, and then then you have to trinomial to factor as well. So that's what I'm saying. Like at the end of the homework, we tend to make the messier problems. Like this one, that 40, the 68, and the 12, those are some big numbers. They're all even, so I know 2 at least will go into them. I would check 12 or 4 or 6. I'd do my factor trees like we did in an earlier example to see what the biggest number is. But if you don't factor out the GCF there, you could have a lot of work on both reverse FOIL or AC method. I said just get in the habit, like the messier it looks, look for those GCFs first. Don't forget that most of these problems are going to have you an example. Um, there's some of them I have to pull from different books. Don't always have the examples. This one has 6 parts remaining, so remember you can just click through, and it'll give you examples. Um, my favorite thing on here is that Ask My Instructor. If you do that, that takes me a link directly to your problem with your numbers. I love using this. This is the most common way that I get to interact with students, especially for my online classes, because not very many students will want to set up. I do one-on-one Zooms. So if this is a factoring is something that's causing you problems, and you want to meet with me, we can do it in person. But I've often done Zooms on Saturdays. There was one semester I had a student who had back surgery, so he couldn't be on his feet for a month. And so, every Saturday, we would Zoom for an hour and go over the stuff for a week. That was in a 14-13 class, so an hour was a little, if it was college out, it probably might have taken us more than an hour, but that's something that I'm willing to do. But I can't help you if you don't ask for help. But this Ask My Instructor, it sends me please put in, if you have an answer in there, a lot of times I can work backwards from your answer. Or ask me a specific question, tell me what part of it is hanging you up, and so I can tailor my answers to you. All right, but that is R5. That is the factoring homework. Like I said, factoring is fair game all semester. You're definitely going to see a lot more of it in Unit 3, but it might randomly show up here and there in Units 2 and 4. But, good luck with this. Have fun with this. Oh, and by the way, um, if you're looking in MyMathLab still, after the R4 and R5 homework, there is a R4, R5 skill check quiz. Right now, it has you have 5 attempts. I'm going to change that to 10. But once you finish your R5 homework, do your skill check quiz. Right? And you get multiple attempts at it and always take the highest grade. So my recommendation is the first time you take it just like a mini test. Take it like it was the test. So don't ask for help, don't look at your notes, don't do any of that. Take that quiz just like you're taking a test. And what that will do is that will help you recognize, even though you did all the homework, are you ready for the testing environment where you only get one shot, you don't get all the examples, you don't get the multiple attempts. That's what these quizzes are for in this class. If you use them to help you, think of them as mini tests, and by the time you get to the test, if you're using them to study, the test should feel kind of redundant, like you've taken it multiple times already, because the test comes directly from the quizzes for the most part. And so if you're missing something on the quiz, if you don't figure out why you missed it, your mindset should be, well, it's going to be on the test. I'm going to miss it on the test again. That's what you should be using these quizzes for. Now, after that first time, what you missed, then I would go back and study. If after that first attempt you want to, you're trying to get a good grade, you can use your notes and stuff to try to get a good grade, but that's why you have multiple attempts. That's why it takes the best grade. So you take it the second time, just try to get 100 on it, and that's fine. But then if there's a couple of problems on the quiz that you're still a little iffy on, then maybe the third time, go back and just do those 2 problems on the quiz and don't care about your grade because you already got a higher grade. Um, so that's how you use these quizzes to study. It's like a feedback loop. So you come into the class with some knowledge. We go over it, with my videos or whatever you're using to study. You do the homework and then see, check the quizzes to see what you know, and then just kind of keep looping. That's all I have for today. Have a good one, and I guess I will see you next time when we do rational expressions.